When you see images like this of this large new solar field in the UAE called the Al Dhafra solar farm, 4 million solar panels, 21,000 square kilometers, 2.4 million tons of CO2 saved, you think, wow, this is the future of energy. We have arrived. It works. Well, let's think about the overbuild of solar. There's a lot of discussion about how much solar do you need to replace, let's say, a gas or a coal-fired or a nuclear-fired power station. So how much is 1 megawatt of solar worth compared to 1 megawatt of coal or gas or nuclear? So let's think about this. Let's assume this is a nice demand curve anywhere in the world. At night a little bit less, during the day a bit more, in the evening a lot. And this is your sunshine. So you assume, okay, no problem. I just have to overbuild by 2 times. I use the energy that is, or electricity is generated during the day for the night. So I move it somehow at night and I overbuild 2 times. That seems logic, not a big deal. Well, it's not as simple. If you go to California, you have what we call a natural capacity factor of 25%. That means, on average, over the year, the sun shines 25% of the time in a usable way. The other time it's either dark, or maybe it snows, or it rains, or it's just cloudy, or dusty, or a hailstorm. So California and Arizona and also South Africa and Australia are amongst the best locations in the world for solar installations with a natural capacity factor of 25%. If that is the case, that means on average what you need to do, overbuild 4 times. Seems logic. Okay, not as big a deal. Well, let's go to my home country, Germany. Germany natural capacity factor is actually 11%. That means on average over the year, 89% of the time the sun doesn't shine in a usable way for the solar panel. So you need to overbuild 9 times. Now, remember one point here. You don't know when these 11% are. You do know for sure they're not at night, but you don't know during the day if it is there or not. Just a few weeks ago, we had a lot of dust from the Sahara Desert, and suddenly, surprisingly, all the utilities were overestimated the solar generation. Now, remember, we have now just in Germany put enough solar up in a perfect world, on average for the year, to move that energy or electricity during the day to the night. So we just come over that one day. Now, let's add backup. Now, backup or storage could be many things. Battery storage are rather efficient. Maybe you only lose 15-20% of electricity in order to have the capacity or the battery work or the backup work. If you use hydrogen for backup, you actually lose 80%. So that means you would have to overbuild on top of the 9 times in Germany, in case of hydrogen, another 5 times. So up to 45 times. If you just use batteries for short duration energy storage, just 11 times. So now you have to overbuild 11 to 45 times. And again, just because you have put a storage in the middle, to move the electricity or store electricity that you generate during the day to use at night. Now you actually have not yet overcome any what we call Dunkelflauten, right, where it's dark for a longer period of time. And if you just use 10 days of storage, because let's say you have to prepare for 10 days of no sun, you would have to overbuild 110 to 40 or 450 times. This is just to give you a sense about the scale and the problem of this intermittency and how to overcome it. Now I realize, of course, there's wind and there's other ways and there's some backup here, some backup there. But when we are talking about an all so-called renewable system, of course, we're thinking of primarily solar and wind, which are intermittent. Hydro we use a lot, which we already probably optimize as much as possible. Geothermal we can use and other things we can use. But when it comes to wind and solar, which are intermittent, you have to think that you have to have at least a large backup storage system in addition to a few other things to make it workable.